Assalamualaikum warahmatullahi wabarakatuh. For today, our title for this assignment is Drying Equipment and Application. Okay, first of all, we have two group members, which is me, Muhammad Dini Iqmal bin Muhammad Fadil, and my friend Muhammad Farhan Kari bin Muhammad Esa. So, for the introduction, the term of drying equipment describes tools and apparatus made to extract moisture from material using a variety of drying techniques. These procedures are employed in a variety of industries, including construction, chemicals, food, and pharmaceuticals, in order to assist prevent spoiling, reduce weight, increase shelf life, or prepare materials for further processing. Drying equipment usually aims to lower a product's moisture content to a predetermined level. There are 8 types of dryers, which is convection dryers, conduction dryers, radiation dryers, vacuum dryers, freeze dryers, spray dryers, free dust bed dryers, and rotary dryers. Okay, for this video, we will talk about freeze drying or lyophilizer. Okay, lyophilization, another name for freeze drying, is a preservation technique that eliminates moisture from a substance by first freezing it and then lowering the ambient pressure to enable the ice to sublimate straight into vapor. This method is frequently used to preserve delicate items like food, medications, and biological samples. For products that must be kept for extended periods of time without refrigeration, the freeze drying method is very popular because it preserves the majority of the product's natural structure, nutrients, and flavor. Okay, there are 3 types of process, which is freezing. The first step is to freeze the products such as food, medicine, or biological samples to a very low temperature, usually for -40 degrees Celsius to -80 degrees Celsius. This turns the water in the product into ice. Second is primary drying, which is sublimation. The product is placed in the vacuum chamber, which lower the pressure around it. Heat is then gently applied to the frozen material. This causes the ice to sublimate, change directly from a solid to a gas without turning into liquid water. The water vapor is removed by a condenser, leaving the material dry. And last but not least is secondary drying, which is desorption. Finally, the product goes through a secondary drying phase where any remaining moisture, water, or vapor is removed. This ensures that the product is completely dry, usually leaving only about 1 to 4% moisture.
Basic principle. The fundamental idea behind freeze drying, sometimes referred to as lyophilization, is to eliminate water from a product by desorption and sublimation. The product must first be frozen before being placed in a strong vacuum with low pressure and low temperature that being applied in order to sublimate the ice. The product becomes dry and stable once the frozen water in it evaporates and eliminated as water vapor. From this diagram, the product will be frozen and converted into water vapor by sublimation, since sublimation requires the addition of heat energy to break the bond between the solid particles. Same sublimation is a phase of transition from a solid directly to a gas without going through the liquid phase. Next, the function of condenser in freeze drying is to collect the water vapor that sublimates from the frozen product during the drying process. The collected water vapor is then removed from the system by the vacuum pump. Terms of the application in industry. The process in terms of application industry, or the process of freeze drying that being used in industry since due to rising customers' demand, FPR safe food items with high quality, fresh light qualities, and novel features. Freeze drying has become a crucial procedure in the food business. Different foods, food additives, and food ingredients can be freeze-dried to extend their shelf life while maintaining their original sensory and nutritional qualities. Due to this, it serves as a good substitute for traditional heat air drying. Probiotics and enzymes are also produced by freeze-drying in the biotechnology industry. Additionally, because it can keep biological molecules active, Freeze drying is widely used in pharmaceutical industry to preserve medication and vaccines. The diagram below is the diagram of the process of freeze drying that is being used in the food industry and also in the biotechnology industry. Advantages. There are 3 advantages of freezing dryer. The first one is maintain better nutritional value than other drying methods. The process also preserves the actual color and shape of the original raw material, reagently consumers that are actually getting real fruits and vegetables in their diets. The intense flavor and aroma of freeze-dried ingredients are also closely resemble the profile of raw material. The second one is the capacity to customize demands and project goals. Freeze-drying ingredients can be cut or grown into many different sizes and shapes. Everything from fruits and vegetables are down to fine powder. Finished product can be easily mixed into any blend or formulation for a flavor profile which is completely unique to the final product. The last one is a method for the long-term preservation of biological matter. It is because freeze drying has been developed to visual bioactive molecule, pharmaceutical products and other medicaid. Lots of pharmaceutical products have used freeze drying as the process for dehydration and improving the stability such as virus, vaccine, protein and colloidal carrier. Deformization is used in the pharmaceutical and biotechnology industry to improve the stability of formulation. The active pharmaceutical ingredient will be solubilized in the water.
For disadvantages, there are 3 disadvantages of this freeze drying, which is freeze drying is slow compared to other drying methods like air drying or spray drying. Second, this makes the process more complex and requires specialized equipment and trained operators. And last but not least, freeze drying is more suitable for smaller batch or high value products.